Greetings and welcome. Today we'll see the examples based on this standard expansion. So if I want to expand 1 plus x raised to x up to x raised to 4. First one is we want to expand 1 plus x raised to x up to x raised to 4. Now if I'll say y is equal to 1 plus x raised to x. If I'll take log on both sides, you'll get log y equal to log of 1 plus x raised to x. If I use rules of logarithm, this will be x into log of 1 plus x. And we know the expansion of log of 1 plus x. What is expansion of log of 1 plus x? It is x minus x square upon 2 plus x cube upon 3 minus x raised to 4 upon 4. If I use this substitution, you will get x in bracket x minus x square upon 2 plus x cube upon 3 minus x raised to 4 upon 4 and so on. Take this x inside the bracket. If I'll take this x inside the bracket, it is x square minus x cube upon 2 plus x raised to 4 upon 3. See, we want terms up to x raised to 4. So, every time write down the series up to x raised to 4. So on. Assume this is equal to z. So, on the left hand side, you have log y. So, you have the expression log y is equal to z. This implies y is equal to e raised to z. Again, we know the expansion of e raised to x, that is 1 plus x square upon 2 factorial plus x cube upon 3 factorial. But instead of x, what you have? Z. So, instead of x, you will get z square upon 2 factorial, z cube upon 3 factorial and so on. In this, we will substitute value of z. Z is our assumption. If I will substitute the value, it is 1 plus z, that is x square minus x cube upon 2 plus x raised to 4 upon 3 plus 1 upon 2 factorial is 1 upon 2 into x square minus x cube upon 2 plus x raised to 4 upon 3 so on bracket square. If I write down the next term, that is z cube, that means cube of this bracket, x square cube will be x raised to 6 which is greater than 4. So, we will not write down the next series, say so on. Now, we will open the bracket, it is 1 plus x square minus x cube upon 2 plus x raised to 4 upon 3. Now, we will take squaring. If you remember, a plus b bracket square is nothing but a square plus b square plus 2ab. We will use this formula to expand. X square is x raised to 4. We want terms up to x raised to 4. So, I will write down plus x raised to 4 upon 2. If I will take next term, that is x cube upon 2, its square, that is x raised to 6 upon 4 which is greater than x raised to 4. So, neglect. Now, if I will check the middle term is 2 times ab. So, multiplication of this 2 along with the factor 2. X square into x cube is x raised to 5 which is greater than 4. So, neglect that term. We are not getting multiplication of these two terms. So, obviously multiplication of these two will be in the expansion and so on. So, what is your expansion? 1 plus x square minus x cube upon 2. If I will take LCM here, it is plus 5 by 6 x raised to 4 and so on. This is expansion of 1 plus x raised to x. येते लक्षात? Now, if I will take one more example, say we want to expand 1 plus x raised to 1 by x up to x square raised to 1 by x. If I assume this is equal to y, take log on both sides. This will be raised to 1 upon x. So, it is into 1 upon x. Multiply by 1 upon x. Now, from this the problem will be changing. If I will take this x inside the bracket, you will get inside the bracket 1 minus x square upon x is x. So, it is minus x by 2 plus x square upon 3 minus x raised to 4, x cube upon 4 and so on. If I assume, say let z equal to minus x by 2 plus x square upon 3 minus x cube upon 4 and so on. This will be 1 plus z. So you have log y equal to 1 plus z. This implies y is equal to e raised to 1 plus z. If we use laws of indices, this is e into e raised to z, that is equal to e into, we know the expansion of e raised to z, that is 1 plus z square upon 2 factorial plus z cube upon 3 factorial, so on. Here we want terms up to x square, so you should write up to square term only. Now in this we'll substitute value of z, that is 1 plus, what is z? This minus x by 2 plus x square upon 3. We want only terms up to x square, so neglect this x cube upon 4 plus 1 upon 2 factorial, that means 1 by 2 into z square, that is minus x by 2 plus x square upon 3, so on, its square. If I write down z cube, it will be minus x by 2 cube, which is greater than 2, so neglect the term and so on. So this is equal to e in bracket 1 minus x by 2 plus x square upon 3. If I will take squaring, minus x by 2 square will be x square upon 4 into this 2. So it is plus x square upon 8. Next term will be x square square, that is x raised to 4, which is greater than 2, neglect the terms and so on. So what is your answer? E in bracket 1 minus x by 2 plus x square upon 3. If I will take LCM, it is 11 by 24 into x square and so on. This is expansion of 1 plus x raised to 1 by x. We'll take next example, say expand or show that, we can say show that log of 1 plus e raised to 2x upon e raised to x equal to log 2 plus x square upon 2 minus x raised to 4 upon 12 and so on. Now if you say this example, I will consider LHS. Say log of, if I separate this denominator to the numerator, it is e raised to minus x plus e raised to x. First we will try to adjust this log 2. Now for this expression, if I multiply and divide by 2, is there any change in the expression? If you observe this, there will be no change in the expression, because this 2 and 2 will get cancelled, will get original e raised to minus x plus e raised to x. So by using rules of logarithm, this can be written as log 2 plus log of e raised to x plus e raised to minus x upon 2. And if we remember the definition of hyperbolic sine cos x, this is definition of hyperbolic cos x. So if I will substitute the value log 2 plus log of hyperbolic cos x, and we know the expansion of hyperbolic cos x, that hyperbolic cos x is equal to 1 plus x square upon 2 factorial plus x raised to 4 upon 4 factorial. If I use that expansion, it is log 2 plus log of 1 plus x square upon 2 factorial, 2 factorial is 2 plus x raised to 4 upon 4 factorial, 4 factorial is 24 and so on. For our convenience, we will assume this as z. So you have log 2 plus log of 1 plus z, where what is z is equal to? Z is equal to x square upon 2 plus x raised to 4 upon 24 and so on. This is value of z. Again we know the expansion of log of 1 plus x, that is x minus x square upon 2 plus x cube upon 3. If I use this expansion here, it is log 2 plus z minus z square upon 2 plus z cube upon 3 minus z raised to 4 upon 4 and so on. Now we'll substitute value of z, that is log 2 plus what is z? X square upon 2 plus x raised to 4 upon 24, so on. This is value of z minus z square upon 2. So it is minus half outside z square, that means x square upon 2 plus x raised to 4 upon 24, so on, its square. We want terms up to x raised to 4. If I'll take z cube will be x square cube. X square cube is x raised to 6, which is greater than 4. So we'll neglect the term and so on. That is equal to log 2 plus x square upon 2 plus x raised to 4 upon 24. Take squaring. X square upon 2, its square will be x raised to 4 upon, so it is x raised to 4. 2 square is 4, 4 into 2 is 8 and so on. With minus sign is there. So it is minus and so on. If I'll take LCM, here 8 and 24. What is LCM of 8 and 24? It is 24. You have to multiply this by 3. Minus 3 plus 1. So you are getting the answer log 2 plus x square upon 2 minus 2 by 24. 2 by 24 is 1 by 12 into x raised to 4 and so on. That's what we want to prove. Check it carefully. If you have any difficulty, you can put the question in the chat box. I will try to reply you personally. Now we want to expand root of 1 plus sin x up to x raised to 6. Root of 1 plus sin x up to x raised to 6. We first simplify this. Say y is equal to, if I use the half angle formula for sin x, it is nothing but 2 times sin x by 2 into cos x by 2. And we can write down value of this one by using first identity of trigonometric function. It is cos square x by 2 plus we can say sin square x by 2. And if you see this complete quantity, this is perfect square of cos x by 2 plus sin x by 2. Bracket square. This square and this square root will get cancelled. You will get cos x by 2 plus sin x by 2. And now we'll use the expansion of cos and sin. We know the expansion of sin x, that is x minus x cube upon 3 factorial plus x raised to 5 upon 5 factorial and so on. And expansion of cos x also. Only what is the difference? Instead of x, what you have here? X by 2. If I substitute the value, it is 1 minus x by 2 bracket square upon 2 factorial plus x by 2 bracket raised to 4 upon 4 factorial minus x by 2 bracket raised to 6 upon 6 factorial and so on. This is expansion of cos x plus expansion of sin x by 2, that is x. X is what? X by 2 here. X by 2 minus x by 2 bracket cube upon 3 factorial plus x by 2 bracket raised to 5 upon 5 factorial and so on. Only you have to expand this and you will get the answer. I will expand few terms for you, that is 1 minus x square. 2 square is 4 into this 2, that is 8 plus x square upon 2 square is 16. 16 into 24. 16 into 4 factorial is 24 minus x raised to 6 upon 2 raised to 6 is 2 raised to 5 is 32, 2 raised to 6 is 64 into 6 factorial plus x by 2 minus x cube upon 2 cube is 8, 8 3 factorial is 6 plus x raised to 5 upon 2 raised to 5 is 32 into 5 factorial is 120. We can carry out the multiplication and you will get the expansion of under root of 1 plus sin x up to x raised to 6. Simply you have to use the formula, half angle formula for sin x, value of 1 by using first identity of trigonometric function. This will become perfect square and use the standard expansion of sin x and cos x. You will get the answer. Thank you for watching the complete video.